Hello there. Welcome to Structuring and Modularizing the Network. This video introduces a modular hierarchical approach to network design, the Cisco Enterprise Architecture. From the last video, we talked about applying methodology to a design. This video begins with a discussion of the hierarchical network structure. The next section introduces network modularization and discusses the details of the Cisco Enterprise Architecture. Following that are the detailed description of services within modular networks and a discussion of network management protocols and features. Let's get started. This video lecture will talk about network hierarchy using a modular approach to network design, services within modular networks, network management protocols and features. And at the end of this video lecture, we are going to summarize each of the module and the entire structuring and modularizing network topic. Network hierarchy. This section explains the hierarchical network model, which is composed of the access, distribution, and core layers. The functions generally associated with each of these layers are discussed, as this is the most common approach to designing a hierarchical network. Historically, it is used in the design of the enterprise local area network and wide area network data networks. This model works equally well within the functional modules of the Cisco Enterprise Architecture. These modules are discussed later in this video in section using a modular approach to network design. Hierarchical network design layers. So as shown here in the figure, the hierarchical network design model consists of three layers. You've got the access layer, which provides the local and remote work group or user access to the network. Next would be the distribution layer, which provides a policy-based connectivity, and a core layer or a backbone, which provides high-speed transport to satisfy the connectivity and transport needs of the distribution layer devices. So each hierarchical layer focuses on specific functions, thereby allowing the network designer to choose the right systems and features based on their function within the model. So this approach helps provide more accurate capacity planning and minimize total costs. Let's have an example. So this figure here illustrates a sample network showing the mapping of the hierarchical model's three layers. So again, these are the access layer, the distribution layer, and the core layer. You do not have to implement the hierarchical layers as distinct physical entities. They are defined to aid successful network design and to represent functionality that must exist within a network. So the actual manner in which you implement the layers depends on the needs of the network you are designing. Each layer can be implemented in routers or switches, represented by physical media, or combined in a single device. So a particular layer can be omitted, but hierarchy should be maintained for optimum performance. The following sections details the functionality of the three layers and the devices used to implement them. Let's start with the access layer. Access layer functionality. So basically, this section describes the access layer functions and the interaction of the access layer with the distribution layer and local or remote users. So the role of the access layer is basically the access layer is the concentration point at which clients access the network. Access layer devices control traffic by localizing service requests to the access media. The purpose of the access layer is to grant user access to network resources. So following are the access layer characteristics. So in the campus environment, the access layer typically incorporates switched LAN devices with ports that provide connectivity for workstations and servers. So in the WAN environment, the access layer for teleworkers or remote sites provides access to the corporate network across some wide area technologies such as the old frame relay, multi-protocol label switching or the MPLS. You also have the integrated services digital network or ISDN, list lines, digital subscribers line or DSL, over traditional telephone copper lines or coaxial cable, and of course, other new technologies that we have now. So, as not to compromise network integrity, access is granted only to authenticated users or devices, such as those with physical address or logical name authentication. For example, the devices at the access layer must detect whether a telecommuter who is dialing in is a legitimate user, yet they must require minimal authentication steps for the telecommuters. So layer 2 switching and the multi-layer switching in the access layer. So access can be provided to access users as part of either a layer 2 or L2 switching environment or a multi-layer switching environment, also known as layer 3 switching. Now, using a layer 2 switching in the access layer, access to local workstations and servers can be provided using a shared or a switched media LANs or local area networks. You also have VLANs or the virtual local area networks, which may be used to segment the switched LANs. So each LAN or VLAN is a single broadcast domain. So the access layer aggregates end user switched 10 over 100 ports and provides fast Ethernet, fast Ether channel, or Giga Ethernet uplinks to the distribution layer to satisfy connectivity requirements and reduce the size of the broadcast domains. You can deploy multiple VLANs with its own IP subset and its own instance of spanning tree protocol or STP, providing alternative paths in case of failure. In this case, layer 2 trunking, so typically using the IEEE 802.1q trunking protocol, is used between the access layer, switches, and the distribution layer switches with per VLAN STP on each uplink for load balancing and redundancy, and with a distribution layer multi-layer switch providing the inter-VLAN communication for the access layer. So the key point would be a recommended best practice is to implement one VLAN, thus supporting one IP subnet per access switch to connect the access switches to the distribution switches with a layer 3 links rather than trunks. When RSTP cannot be implemented, the Cisco iOS STP features such as uplink fast, port fast, and backbone fast can be used to provide equivalent convergence improvements. So these features are described as follows. Uplink fast enables faster failover on access layer switch on which a dual uplinks connect to the distribution layer. The failover time is reduced by unblocking the blocked uplink port on a switch immediately after the root port failure, so thereby transitioning it to the forwarding state immediately without transitioning the port through the listening and learning states. Next would be the backbone fast. If a link fails on the way to the root switch but is not directly connected to the local switch, backbone fast reduces the convergence times from 50 seconds to between something like 20 and 30 seconds. And the last one would be port fast. Enable switch ports connected to a non-switch devices such as workstations to immediately enter the spanning tree forwarding state, thereby bypassing the listening and learning states. When they come up, so that is where the port fast will take over. So ports connected only to an end user device, workstations, computers, do not have bridging loops. So it is safe to go directly to the forwarding state, significantly reducing the time it takes before the port is unusable. So if you want to learn more about this STP, you could go ahead and check the supplementary videos about STP. Now, using a multi-layer switching in the access layer, the most common design for remote users is to use multi-layer switches or routers. So a multi-layer switch or router is the boundary for broadcast domains and is necessary for communicating between broadcast domains, including VLANs. So access routers provide access to remote office environments using various wide area technologies combined with multi-layer features such as route propagation, packet filtering, authentication, security, and of course the QoS or the quality of service. So these technologies allow the network to be optimized to satisfy a particular user's needs. In dial-up connection, dial on demand or the DDR, okay, and static routing can be used to control costs. Let's have an access layer example here. So this figure illustrates a simple network in which the campus access layer aggregates end users and provides uplinks to the distribution layer. So the access layer switches are dual attached to the distribution layer switches for high availability. The access layer can support convergence, high availability, security, quality of service or QoS, and IP multicast. So some services found at the access layer include establishing a quality of service trust boundary or the QoS trust boundary, broadcast suppression, and the Internet Group Management Protocol or IGMP snooping. So in here, workstations are attached to VLANs with layer 2 switches. So the recommended practice, implement one VLAN. That means one IP subnet per access switch. So access switches connects to layer 3 links if only one VLAN per access switch or via VLAN trunking. Okay, so if needed, a distribution routers route between virtual local area network. Let's talk about distribution layer. This section describes distribution layer functions and the interaction of the distribution layer with the core and the access layers. So the role of the distribution layer, basically, it represents both a separation between the access and the core layers and a connection point between a diverse access sites and the core layer. The distribution layer determines department or workgroup access and provides policy-based connectivity. So following are the characteristics of the distribution layer. So distribution layer devices control access to resources that are available at the core layer and must therefore use bandwidth efficiently. In a campus environment, the distribution layer aggregates wiring closet or the telecommunication closet's bandwidth by concentrating multiple low-speed access links into high-speed core link and using switches to segment work groups and isolate network problems to prevent them from affecting the core layer. So similarly, in a WAN environment, the distribution layer aggregates WAN connections at the edge of the campus and provides policy-based connectivity. This layer provides redundant connections for access devices. Redundant connections also provide the opportunity to load balance between devices. So the distribution layer represents a routing boundary between the access and the core layers and is where routing and packet manipulations are performed. So the distribution layer allows the core layer to connect diverse sites while maintaining high performance. So to maintain good performance in the core, the distribution layer can redistribute between a bandwidth-intensive access layer routing protocols and optimized core routing protocols. So route filtering is also implemented at the distribution layer. The distribution layer can summarize routes from the access layer to improve routing protocol performance. So for some networks, the distribution layer offers a default route to access layer routers and run dynamic routing protocols only when communicating with core routers. The distribution layer connects network services to the access layer and implements policies for the quality of service, security, traffic loading, and routing. So, for example, the distribution layer addresses different protocols' quality of service needs by implementing policy-based traffic control to isolate backbone and the local environments. So policy-based traffic control prioritizes traffic to ensure the best performance for the most time-critical and time-dependent applications. So the distribution layer is often the layer that terminates the access layer VLANs, broadcast domains. However, this can also be done at the access layer. So this layer provides any media transitions, for example, between Ethernet and the WAN technology. Okay, so that must occur. So this includes policy-based connectivity. So when you say policy-based connectivity, this means implementing the policies of the organization as described in applying a methodology to a network design video. So what are the methods for implementing policies? So this includes filtering by source and destination address, filtering based on input and output ports, hiding internal network numbers by route filtering, providing specific static routes rather than using routes from a dynamic routing protocol. For security, okay, so you could have, for example, certain packets might not be allowed into a specific part of the network. So you also have the quality of service mechanisms, for example, the precedence and the type of service or TOS, okay, so or the TOS value in IP packet headers can be set in routers to leverage queuing mechanisms to prioritize traffic. So basically, the distribution layer provides link between the core and the access layer. Let's have the distribution layer example. So this figure shows a sample network with various features of the distribution layer. So following are the characteristics of the distribution layer in the routed campus network shown in the figure. So the multi-layer switching is used to forward the packets going to the access layer, and in this case, within the access layer. So multi-layer switching is performed in the distribution layer and extended towards the core layer. The distribution layer performs a two-way route redistribution to exchange the routes between the routing information protocol version 2, okay, so which is RIP version 2, okay, and enhanced interior gateway routing protocols, or the EIGRP routing processes. So this could be any routing protocol. So it could be OSPF and EIGRP and vice versa. It could be any routing protocols. Now, route filtering is configured on the interfaces towards the access layer. Route summarization is configured on the interfaces towards the core layer. The distribution layer contains highly redundant connectivity both towards the access layer and towards the core layer. Now let's talk about the core layer. The core layer functionality. So this section describes core layer functions and the interaction of the core layer with the distribution layer. So the role of the core layer, the function of the core layer is to provide fast and efficient data transport. So characteristics of the core layer includes the following. So the core layer is a high-speed backbone that should be designed to switch packets as quickly as possible to optimize communication transport within the network. Because the core is critical for connectivity, the core layer devices are expected to provide a high level of availability and reliability. A fault-tolerant network design ensures that failures do not have a major impact on network connectivity. The core must be able to accommodate failures by rerouting traffic and responding quickly to changes in network topology. The core must provide a high level of redundancy. A full mesh is strongly suggested, and at least a well-connected partial mesh with multiple paths from each device is required. So the core layer should not perform any packet manipulation. Okay, so such as checking access lists or filtering, which would slow down the switching of packets. So the core layer must be manageable. The core devices must be able to implement scalable protocols and technologies and provide alternative paths and load balancing. So let's have an example of the switching or multi-layer switching in the campus core. So layer 2 switching or a multi-layer switching, which is also known as a layer 3 switching, okay, or routing, can be used in the core layer. So because core devices are responsible for accommodating failures by rerouting traffic and responding quickly to the network topology changes, and because performance for routing in the core with a multi-layer switch incurs no cost, most implementations have a multi-layer switching in the core layer. So the core layer can be then more readily implement scalable protocols and technologies and provide alternate path and load balancing. So the figure shows an example of a layer 2 switching in the campus core. So in the figure, a typical packet between access sites follows these steps. So step 1, basically, the packet is a layer 2 switched towards the distribution layer, okay, or the distribution switches here. Step 2, the distribution switch performs multi-layer switching towards a core interface. Okay. Now, step 3, the packet is a layer 2 switched across the LAN core. The distribution receiving switches performs multi-layer switching towards an access LAN or the access layer LAN here. Okay, this is step number 4. And step 5, the packet is layer 2 switched across the access layer LAN to the destination hosts connected to this layer 2 switches here. So routing in the WAN network. So this figure here shows an example of a multi-layer switching in the campus core. So this is a typical packet between access sites follows these steps here. So basically step 1, the packet is layer 2, okay, switched towards the distribution layer or the distribution switches. Okay. Step 2, the distribution switch performs multi-layer switching towards a core interface. And then the packet is multi-layer switched across the LAN core. Step 4, the receiving distribution switch performs a multi-layer switching towards the access LAN, okay, or towards the access layer. And then last one would be the packet is layer 2 switched across this access layer LAN to the destination hosts connected to this layer 2 switches here. Now, to summarize, the hierarchical network model provides a modular view of a network, making it easier to design and build the network. The purpose of the access layer is to grant end user access to network resources. The distribution layer provides aggregation for the access layer devices and uplinks to the core layer devices. It is also used to enforce policy within the network. And then the core layer provides a high-speed, high available backbone designed to switch packets as fast as possible.